The lesson we're currently working on is basically, again, about the applications of normal distribution. And what we kind of want to finish this up with is how we can use those applications to tell if something is normally distributed. Determining normality. There are several ways statisticians check for normality. The easiest way is to draw a histogram and check its shape. And that's going to be like step one. If it's not bell-shaped, or not even kind of bell-shaped, because remember a lot of this is approximately normally distributed, we don't have to go any further. But if it gives you an approximate bell-shaped curve, then we want to check for skewness, and we're going to use Pearson's index. And that's going to be step 2 here. And our formula for Pearson's index is we're going to take 3 times the mean minus the median divided by the standard deviation. And I will apologize in advance that we are again going to have to find standard deviations of group data. And I'll take you through an example or two to help us remember. Anyway, if it's greater than or equal to 1 or less than or equal to -1, then we can say that it's significantly skewed. And then step 3, we're going to check it for outliers. Now remember, that's where we find our interquartile range, and we're going to go quartile 1 minus 1.5 times the interquartile range, quartile 3 plus 1.5 times the interquartile range. Again, I'll show you an example. But it says even 1 or 2 outliers can have a big effect. Try something different. Even 1 or 2 outliers can have a big effect on normality. Again, is the data normally distributed or approximately normally distributed? So let's go through an example about using our 3 steps. I'm going to apologize again. On your notes, I did not leave you enough room. So I don't know if you want to redo the frequency table here, and you're going to see what I mean in a minute, because again, we're going to have to find the midpoints to find the standard deviation, and then we square that and multiply by the frequencies. It'll come back to you. We're just going to try an example. Survey of 18 high technology firms showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed. So step 1, step 1 is creating this table and the histogram. Okay, so I know you don't have that, but I've kind of already went through and have that done for you here. Here's our classes and our frequencies. Here's the data up here, and the good news is this data is listed in order, and that's going to be important here in a second. And if you look at the histogram you get, it doesn't look exactly bell-shaped or normally distributed, but it's kind of close. So we want to continue along with our steps. And if you have any problems creating the frequency table or anything, let me know. So remember, step 2 then said we want to use Pearson's index. And this is going to be step 2. And our Pearson's index says you take 3 times your mean, subtract your median, and divide by the standard deviation. Let's go back to our data up here. This data is listed in order, which is nice. We don't have to take the time to do that. And we know that there are 18 of them. So to find our mean, basically, remember, we're just going to add them up and divide by how many there are. So if I were to add this first column up, I would get 436, I believe. And if I add the second column up, I'm going to get, or I'm sorry, I shouldn't say columns, I should say rows, 995. Again, all I'm doing is 5 plus 29 plus 34 plus 44, so on and so forth. So if we add those together for our total, dividing by 18. Okay, so again, here's what I'm doing. I'm adding all these numbers up. I broke it into rows just so I could try to prevent myself from making a mistake. And when you do that, you get about 79.5. Do not know why I did not write 79. Let's try this again. 79.5. Okay, so our mean is going to be 79.5. Okay, mean is just like always, like we've always found. The other piece of information we need is the median. Well, there's 18, okay, so to find the median, we got to find the middle since they're in order, and it's going to come right between the 74, because there's 9 and there's 9, and the 81. So if you had 74 plus 81 and divided by 2, we get 77.5. Sorry, that's 77.5 there. Okay. Have our mean, have our median, and now our standard deviation. Sorry that we have to do this again. This is, if you think back to what we did, I believe it was in chapter 3. You had to find the midpoint, and then we were going to do the frequencies times our midpoints, and then we were going to do the frequencies times our midpoints squared. So our midpoints, we just, remember to find the midpoint, you add 5 plus 29 together and divide by 2. And that works out to be 17. Add 30 and 54 together, divide by 2. We get 42. 55 plus 79 together, divide by 2. We get these midpoints, 67, 92, 117, 142, and 167. Now we're going to go our frequencies times these midpoints. So basically 2 times 17, which is 34. 3 times 42, 126, and so on and so forth. Oh, sorry if I'm going off here a little bit. Alright, and the last step is we're going to take our frequencies times our midpoints squared. So 2 times 17 squared, 3 times 42 squared. And we get these numbers. Again, this is all stuff we did a while ago. And then we're going to want to take the summation of these. We know we have a frequency of 18. We don't have to worry about adding our midpoints up. This summation, we're just adding them together, 1,431, and then this one, 141,577. So now that we have all of those numbers, we can place them into our formula, and hopefully all of this is starting to come back to us. And the formula is actually I'm going to give you is for the variation, because we just have to take the standard deviation. So that formula is going to be our n, that's our frequencies, times the summation of our frequencies times the midpoint squared, and then subtract off the summation of our frequencies times our midpoints, that whole thing squared. And then we divide it by our frequency times our frequency minus 1. Okay, so let's look what these numbers come from. Our frequency is 18, frequency. This one right here, the summation of the frequencies times our x squareds, that's this column. Okay, so we're going to go times 141,577. And then we're going to subtract off this number right here and then square it. 1,431 squared. And then we're going to divide by 18, well, times 17. Whew. Again, careful plugging that into your calculator. Kind of do this first part here, hit enter, and then divide it, and open a parenthesis up and go 18 times 17. And what that gives us is 1,636.03. That's approximate. It goes out a little bit further. But then, again, that's the variance. We had to take the square root of it to find our standard deviation. And that then is going to be approximately equal to, we'll say 40.5. So S equals 40.5. All of that work, I know we missed doing it, not really. But anyway, what it does is it gives us the ability then to figure out how skewed the data is, if it's significantly skewed. So we're going to go 3. Once we have all these numbers, it becomes kind of easy. Something should be right. 79.5 minus our median of 77.5, and then we divide that by about 40.5, and that gives us 0.148. Okay, well, what does that mean? Well, remember, if it's greater than or equal to 1, less than or equal to -1, it's significantly skewed. Okay. So we can say not significantly skewed. All right. Step 1, step 2, here comes step 3. And again, I'm going to apologize if you're running out of room on your notes. Step 3, we need to look for outliers. So I'll add a page in here. The way we find outliers is we can take our first quartile, and then we're going to take 1.5 times the interquartile range. And then we're going to take quartile 3, and we're going to add 1.5 times our interquartile range. And that's going to kind of give us the range that all the numbers should fall in. So let me real quick grab these numbers. Okay. Again, they're in order, which makes it easy for us. Sorry about the bell. They're in order. Our median, remember, was right here, in between these two. So I can look to the left here, and there's 3, 4, 5, 6, 7, 8, 9. So the middle one is going to be our first quartile. If you can remember doing our quartiles, it breaks it up into 4 parts. So here's 1, here's 2, because that was our median, and then we break this second row up here, and here's quartile 3. Okay, again, the quartiles, we have our up to our first quartile, up to our median, up to our third quartile, and then to the end. So to find our interquartile range, we're just going to take 98 minus 45, and that gives us 53. Now we can kind of use these formulas here. Our first quartile is 45, so I'm going to go 45 minus 1.5, 1.5 times our interquartile range. And that's, let's see, a negative 34.5. And then our third quartile here is 98 plus 1.5 times our interquartile range. Now we're adding it because we're trying to expand our range out to see if all of these numbers fit into it. And that works out to be 117.5. Okay, so to check for outliers, we want our numbers to lie between negative 34.5 and 117.5. And if you look up here, that's not quite right, and I think I made a mistake in my math, so I apologize, because I know you're already stressed out about having to do all this stuff. It's not 117, it's 177. Sorry about that. 177.5. That makes more sense. So our numbers should all lie between negative 34.5 and 177.5, which they do. So we can say that there are no outliers. So to kind of sum up all of our steps here, it's approximately bell-shaped, it's not significantly skewed, and there are no outliers. So we can conclude that the distribution is approximately normally distributed. Again, follow these 3 steps, and then you can kind of come up at the end is whether you can remember we're checking for normality, and that was our goal from the start. And if you go through all these steps and it kind of passes all the steps, you can say data is approximately normally distributed.